Hello everyone. Today we are going to have a short demo of the Einscan Pro Plus 3D scanner that you can see behind me. So here I am at Embry-Riddle Prescott Rapid Prototyping Lab, and we are going to show you a demo of 3D scanning. So this 3D scanner that you can see behind me is, as I said, called Einscan Pro Plus, and it can operate in two different modes. It operates in handheld, so you can take it off the tripod and you can use it in handheld. If the object is big, then all you need is to just scan the object by moving your hand gently and in a consistent manner around the object. And by that I mean you don't jump from the left side to the right side and stuff like that. You have to move continuously in the same direction so that the scanner can keep track of where it is. Okay, and it also comes with this extra addition here that captures the color and texture, right? Especially color. So here you have the projector in the center, you have the two cameras on the left and the right. And as I said, this extra addition you can add on the top to capture color. So it captures both geometry and color texture. And if the object is small and you want a more accurate scanning, then you can put it back right on the tripod. And the size of the tripod, the height of it, everything can be settled to your needs. This is our turntable here. Let me show you. So this is our turntable. It has color-coded surface. So each one of these shapes, as you can see, on the circumference of the turntable, they have a specific shape. And by looking at those, the scanner can determine how much it has rotated so far. It can accommodate up to 2 kilograms and an object of almost the middle of it, really. What you shouldn't be doing is your object should not be sitting on the top of this color-coded, at least most of them, and occluding them, because then it cannot track you. And then it has to use visual features. So either the object has to have prominent visual features, or you have to use these markers that I'm about to show you, so it can keep track of how much it has rotated. Okay, so this is your turntable, and as the object is small here, in this case, like this eagle that we 3D printed. By the way, this is a 3D scan version. So the actual eagle was about like 80 centimeters or so. So I scanned it and then printed a smaller replicate of it that you can see here. So you put it on the turntable. And the important thing is when you launch the software, so you can see the software here, right? This is this software called Einscan Pro Plus. When you launch it, then it says, is it Pro or Pro Plus? If I choose Pro Plus and I go to next, then it asks you, is it a fixed scan on tripod or is it the handheld? For me, it's a fixed scan, so I go forward. And then it says, do you want it with the turntable color-coded or without the turntable? That's using visual features. In this case, I want it with the turntable, and I say next. And now, when it turns on, you see there will be, and let's give it a name. So I would just call it Eagle and save that. And here you can say whether you want the color or not. Let's say I want the color and texture. Now, let me move the webcam so you can see better. So now if you look, if I move it up a little bit from here for you, let me see if I can move it without interrupting my video. Let me bring it closer to the scanner for you. So now you can see a crosshair here, right? There is this crosshair, and you try to put that crosshair right at the center of the turntable where the object belongs, okay? And then using that, you should be able to focus on the part. So here we go. I move my turntable a little bit further away, like here, right? So now the crosshair is at the center. and then I put my eagle on it. So now it is at the crosshair, and then I will what? I will use these two kind of paste objects that stick to the print bed very well, and they are very good if the object is not stable when you put it on the turntable, or you want it's very lightweight like this. So there is a small chance when the turntable is spinning, you get the object displaced. If the displacement happens during the scanning, your scan is literally ruined. You have to make sure your object is as stationary as possible. So as I said, you can use these two pieces and kind of attach it to, not attach it, but a little bit fix it to the scanning turntable. Basically something like this. So they stick very well to the bed, and they can deform and adapt to the shape of the bottom of the part. So now the eagle is in good place, and it is at the center of your scanner. And now all you need to do is to go to the software and do the settings. So let me move over to the software. So here is our software. It has some settings, okay? Here is the preview of your part. Now, if the camera projector, if the scanner projector shines a lot of light, you're gonna see the color-coded objects will turn very, very red. So let me bump up the intensity here. You see? Now you have a lot of red spots. When that happens, it means your projector is too bright. So always make sure you don't have a ton of red spots, okay? Minimal as possible, like this. This is a very good start point. And then you can also see the right camera. This is just a view of the left camera. If you click here, you can also see the right camera. Or you can turn on, make it color camera, so you can see the object in color. If you don't care about those, then you can come here and see whether you want the high definition scan or not. So you can turn it on or off by dragging this. I want a good scan, so I turn it on. And here you tell it how many stops do you want in one full revolution for the scanner turntable. So you can stop in 2 positions. So every 180 degrees, do a stop and scan again. Or you can go 180 stops, so basically every 2 degrees. So I think for this case, something like 12, which is every 30 degrees, should be good enough. And then you say whether you want the scan to be done with the turntable coded target or with the features. And since my color-coded targets on the turntable are not occluded, I would definitely use those. They always allow for a better scan, right? Instead of the scanner trying to look for visual features. Okay, so now you might say, well, if my object does occlude, the base of the part is big, so it occludes a bunch of these color-coded kind of arcs, then what should I do? Well, then you can turn on the features. And if you say feature, it means it tries to find visible features on the part, like specific corner points, edges, and so on, depending on how the software features are defined. And if the part is too simple, right? I mean, like there are no specific features on the part. Let me show you an example. So here, assume you have something like this. This is a small section of a wing, right? Other than the corners, there is barely any visual feature for the scanner to track and know its 3D position or the 3D position of the object with respect to the scanner. So especially because also the part is of uniform color as well. So it's very hard to track anything on this. So one thing you can do is to use the markers. And these markers, as you can see them here, right? You can see, especially on the bottom of this bridge, this truss here, we put these markers. So they come also with the printer, a pack of these, a bunch of them. And you put them, and the scanner can easily track these guys. The two important things about this, the two important things about this markers is, one, you should spread them randomly on the surface. By no means you put these markers completely uniformly. Okay, that's not a good thing. Two, when you do scan using the markers, and when your scan is done, right below these markers where the scanner could not capture the geometry, you see some holes. And so you have to use this scanner software or an STL manipulation or handling software like CATIA, like Fusion, like any other software to fill the holes for you. Okay, so you will get some holes. That's the drawback of these markers. But if there is no other way to go about it, then this is your solution. That's one thing. The other thing I wanted to emphasize is the objects that are either shiny or transparent, like let's say the cap of this bottle, okay? If you look at this object, this is kind of transparent, right? Or if you, let's say you have a piece of very shiny metal. If you want to scan those, you're not going to get any good scan, okay? Because there is a subminimal reflection or it's a specular reflection instead of Lambertian, and that ruins your scan. So if you see such a thing, transparent, or as I said, shiny, or for laser scanners, it's really black, so absorbs the light a lot, then the solution to go is a CAD-CAM spray like this. Okay, these CAD-CAM sprays are amazing. They are cheap. Each bottle of them is like $2, $3, $4. And they spray a very, very thin layer of basically a mist of a white powder on the object that sticks very well, and then you can easily wash it. And it makes the part opaque, and the color of that is optimized for the scanner to capture the geometry. Okay, and if you don't have these, you can even use baby powders. Just make the surface of the part wet and then use baby powder and just very, very gently spray a mist of baby powder. Try to not give it any thickness or bumps on the surface of the object. That's your second best solution if you don't have access to these CAD-CAM sprays. So now that I told you some important stuff about the software, about the lighting of the environment and everything, about the light of the camera, the head that should not be really shiny, we can start the scan. If you see, again, if you see for any reason you don't get a good scan, you might change the lighting of the environment and make sure you don't have a very, very bright environment. Especially if your scanner has what? Has white light instead of blue light, because white light is typically affected so tremendously by the environment. So here, let me go ahead and basically change the illumination of the environment. There we go. So now the environment is more under the control. And now I'm going to click on the basically on button here on the scanner and let the scan start. So here we go. Okay. So now the scan is going to start. Let me turn my webcam a little bit toward the eagle. There we go. As you can clearly see, the geometry is showing itself here. And the other thing that you can see is the pattern of light. As you can see, the light that is shining on the surface. Look here, it is definitely, there we go. You see, there are parallel lines like a barcode, and those parallel lines will deform when they are shining on a surface with ups and downs. And the amount of deviation of them, deformation of them, is proportional to the height of the surface. So that's how the structured light scanner like this one works. And you clearly see that structured light here, right? I'm going to move my webcam close. Here we go. Let's see. Right, you clearly see the parallel lines here. And then we are going to put it back. Let me show you the geometry also being captured. In the software, what you can do is you can use your mouse and you can see the 3D shape being captured. So, so far the scan was not really so great, as you can see. It did not get much of a geometry, and that means the lighting of the environment, the position of the eagle is not really optimal. And you can probably see, because if you look at the light here, the light of the scanner is just covering from this area all the way to the front. So really, I should have brought the turntable a little bit forward toward myself to get a better focus of the eagle, and maybe raise the camera or bring it closer. So make sure you adjust the illumination of the environment, the distance, the location of the turntable with respect to the camera, so that you get a little bit better. All you can see here is just the very bottom of the eagle is being scanned. That means the top of it is never on the focus of the scanner. Okay, so what I need to do is to go ahead and stop the scan, and then basically discard the current scan, then go adjust the location, the illumination and everything, and you see here it goes away, and restart my scan for you here. Okay, so here I coated the eagle with the CAD/CAM spray because the material that was printed from had the metal particles, so it was a little bit shiny, and it has too many basically cavities and too many surface deformations, so it was not really ideal for a good scan without any help. So I applied the CAD/CAM spray, and as you can see, the eagle is definitely white now, but it is no big problem. You can always wash it with water. But now you can see I'm getting a very beautiful scan, and you can move it. You can look at it while the scan is being done, right? As you can see, clearly the scan is made of really thousands and thousands of points. Okay, that's what the scan is. If I move my camera a little bit closer, you can clearly see that right now I have about 1.3 million points, right? And 1.212, right? Now 1.37 million triangles that are estimated to connect these points together and perform tessellation. So here, let me show you. When you zoom in, you clearly see is thousands and thousands here, 1.6 million points, and that's because of this HD here. If you turn on the HD, the number of points is going to be quite less. Of course, you're not going to get as good at the scan. The other thing you have to pay attention is when you do the scan, it captures a bunch of other things on the surrounding. You see, it captures the parts of the surrounding of it, the wires, the turntable itself, and so on. But that's not really hard to clean up once your scan is finished. Okay, so you see the scan is almost done, one full round. So let me put it back. And then I'll show you how to clean the scan. So it's almost done. Once it goes one full revolution, then it shows you that the scan is good. There we go. So you see now, if I show you, it shows that green mark and red mark. And before you click on the green mark and evaluate the Einscan, which is always asked for, you make sure you use these options here. Let me show you these options, again from a close distance. So these options, as you can see, are for throwing a part or all of the scan, for reversing a selection, for deselecting, for undoing, and so on. So if I want to, let's say, throw a part of this scan away because it is not really the data that I want to save, I hold down the shift button from the keyboard, and then using my mouse, I drag a shape using S-splines around the area, and then once it's highlighted in red, means that area is the one that is going to go. So here I'm going to put this back and I hold down the shift button, I zoom in, and any area that I don't want, I try to highlight. Right now, the area inside, which is the eagle, is highlighted. So if I say delete, it's gonna delete the eagle. But if I say revert, it's gonna select all of the points except those areas. So now everything is red is gonna be deleted, and that's what I want. I delete, there we go. So now my scan is much, much cleaner. And now if you want, you can also trim to a good extent those sticky parts that you use to stabilize the eagle. So now I can go here and I can mark off a portion of it like this. There we go, right? And then make sure if there are isolated points, you clean them up. It's much easier to do it here than later using a software, okay? So try to do the best cleaning you can before doing anything else. So let me do another portion here. And there we go. So now it has captured the eagle, of course, partially, not entirely, right? You see, definitely there are areas in yellow, if you can see, right? And these areas in yellow, they are holes. The scanner could not capture them properly. There are some parts on the front of the eagle that the scanner could not capture, and also definitely at the bottom of the parts. So this is not done yet. We need to now turn the eagle at different angles and try to keep scanning and then merging the future scans with this one to remove as many holes as possible before we export it as STL file. So right now I'm happy with this scan. I say okay, and this is all I could get in this scan. But now, as I said, I can turn the eagle to a different angle and start my next scan. Okay, so here I have turned the eagle on its back and trying to get another scan of the part. And then my goal is to merge this scan with the previous one. If the scanner can do a good job and merge the two scans without too much of error, then you accept the merging. Otherwise, it gives you an option to manually select 3 points on each one of the scans, and then by saying which point belongs to which in these two different scans, it tries to find a matrix relation between the two scans called the homography matrix, and then transferring the points from one scan to the other and merge them into a bigger scan. So that's the secret to get a final good scan, is whether you can merge these different scans at different angles to a nice clean final scan. Okay, and that's where the goodness of the software come in, whether your scanner has a good software that uses different types of cues, color, texture, and other visual features to merge, or it's just using some simplistic approach. So clearly you see now I'm getting a lot better scan from the front part of the eagle. The number of holes is reducing, and we'll see whether these two scans can be merged properly together or not. So let me move over here. There we go. Now, again, before I finalize and click on the green check mark, I need to do the cleaning and get rid of the erroneous parts. Now you also can see that the bottom of the eagle is scanned too, something that was completely missing in the previous one because the eagle was sitting on the bottom part of it. So first, let's do the cleaning. Again, holding down the shift button, selecting the areas that I want, and then reverting it and deleting. And then again, any area you don't want, any erroneous data, any isolated points, try to get rid of it here, not take it to a software later. And let's get also rid of this stabilizer parts here on the sides. There's one here, and let's see, yes, we've got the other one also. This is completely isolated. There we go. So now this is a lot better. And now when we OK, it tries to merge them together. Let's see if it can. Yes, you see it could without too much of headache, right? And now if you look, many of the holes in this area that you had, you don't have, and the bottom of the eagle is also what? Covered, but now you got the back of the eagle that has a bunch of holes in it. So now it is your time to turn the eagle on its back and perform another scan. Let's see if I can stabilize it. There we go. And now we perform another scan. Okay, so here I have done the scan also on the back, and again, I'll try to do a cleaning. Oh, it's okay. And then merge this last one. And hopefully I get somewhere close to something that I can export. Again, try to clean as much as possible. Okay, so the back scan is good to go. I accept it. It tries to merge again. And then it asks you whether you're happy with the merging. So if you go and look, you see now it covered a bunch of the areas on the back. So now the number of holes is significantly less. And as I said, if you don't like that, you can click on this option here. If you can see, it has these dots right below the play. And when you do that, then it shows you the two previous scans. And then you have to hold down Shift and then select 3 points here and then do the same thing for the bottom view, which are the previous scan and the current scan. And then it tries to calculate the projection required to merge them together. Let's see here, I'm okay with this. So now it is time to click on this button here above the save, which is going to export it for you. At first convert it into a mesh file, then you can export it with save. So when you do here, it does the tessellation for you, and it's either unwatertight or watertight. Unwatertight means it's not going to try to fill in the holes for you. Watertight means it tries to fill in the holes. So for this here, because I don't have too many big holes, I try to go watertight. If the holes are big, I don't recommend you do watertight because you're going to see big bulges at the location of the holes. Okay, it does not necessarily do an amazing job filling the holes when doing tessellation. So here I don't have too many holes and they are not big, so I try to do watertight. You can choose how much of detail you want here to make it fast. I go low details, and then it is going to start saving your tessellating basically, and then you can save it as an STL file or any other file, right? Okay, so now it is tessellated, and now you can choose whether you want it to be simplified and whether you want it to keep it smooth or with sharp details. So here, let's say I want it to be sharp, and then by simplification ratio, it tries to kill the redundant number of polygons, the triangles really, and the points, and reduce the size of the file. Because you see right now the STL for me is 35 megabytes, but if I choose like 50%, it brings down to 17 megs, right? And then you apply that, and now it is going to try to preserve the details in sharp and not smoothen it, and trying to basically reduce the size of the file. Now, as you can see clearly, if you look at the part, it is now a surface. There is no point anymore. If I zoom in, hopefully you can see the triangles now, right? So definitely it is now tessellated. It is a surface. It is a mesh file. And as you can see, now the eagle is in relatively good condition. Now, of course, you might see some erroneous data here, which is definitely at the location of the holes. When I did it watertight, it could not do a perfect filling of the holes because it has no clue how to fill them. But you clearly can see it got a relatively good scan of the part. The accuracy of this guy is basically 0.01 millimeter in the handheld and in the turntable, and when it goes to handheld it is a little bit less, but you clearly see the scan is done, and now I can save it as .stl file wherever I want, correct? So and this is the file that you can import in your mesh processing, STL processing software. You can also scale it here at the end if you want to make it smaller or bigger. And now that STL is ready to be imported into a software, and you can do replicating it, you can clean it up, you can take it into CATIA and smoothen out those areas with those bulges. Please watch my video on Digitize Shape Editor, and you see the ironing tool in CATIA that you can smoothen out these areas and get yourself a good replicate. So this is about the turntable. The last thing I wanted to show you briefly is the handheld mode. So you can use handheld or handheld rapid. Here I use handheld rapid. Go to next. And as I said, this is really good for heavy parts, for big parts that do not easily fit on the turntable. You can use the handheld. And you can use markers on the part if the part is too simple, too uniform texture and color. If not, then you can simply just use the camera in handheld, the scanner, and then you can what? You can really start scanning. The important thing is keeping the distance between your scanner and the eagle, the part really here, because if you get it too close or too far away, it is losing the track of the position of the eagle, right? Or your part in this case, as I said. So, because when you calibrate the scanner in the first time that you use it, you are setting it up for a specific distance, which in this case, I guess it is about 2 feet or so. So if your distance is far away from that, you're definitely going to see the scanner beeping and saying, hey, I'm losing track of the scan. Try to go back to the last known position and orientation. So keep that in mind. Okay, so now I'm in the handheld, and this is the scanner. Let me see if I can turn it a little bit better so you can see the scanner at the same time with the part. There we go. So the first thing, it allows you to do a checking, see whether it can capture. And now if I move back even a little bit further, you can see under the preview that you see those green points. And when those green points are there, means yes, I can capture. So now I'm going to move this further back if I can and squeeze the scanner. in the same location. And you clearly see if it's too close or far away or something, it tells you in red here. So now I click on, and now it starts to capture data, right? I recommend you hold it in position if it has too many details, right? But now we can gently move it to other directions. Don't go fast. You see, if you go, it says tracking lost, or if you get too close or too far away. Handheld scanning is a very sensitive thing. You should not rush it. You should avoid abrupt, sudden motions from side to side. You have to be really patient and try to really capture the part at all different angles. Okay, so let's say for the moment this is good enough, so I can click on the capture button here, and I can zoom out for you so you can see that I could capture something, right? And now if you look at the data captured, you definitely can see that the quality of the scan is not comparable to the turntable. Okay, so even if I convert it into a surface, still it's not going to be so nice because my hand quite bit has some redundant vibrations. Okay, and everybody hand does, unless you attach it really to a robot and let the robot and effector move smoothly and uniformly all around the object. The quality of your handheld scan is definitely smaller than the turntable, but the good thing is it allows you to capture bigger, heavier parts. Okay, so hopefully this video was useful to you, and I will see you in my next video on 3D printers and 3D scanners. Thank you.